Hello, I'm Jacob from Intrepid Protoworks, and today we are going to learn about skew and kurtosis as we start to learn about the shape of a distribution of data. If you are new here, this is a continuation of our statistics using Python series. And you should go ahead and take a look at our past content before looking at this video, unless you're already familiar with concepts like standard deviation, variance, mean, mode, etc. Now, kurtosis is basically how pointy a distribution is. A better way to describe it is how big the tails are in reference to the middle of the distribution. So if the tails are the same thickness of the distribution, then that is a certain type of kurtosis. If the middle of the distribution is really pointy, then that's another type of kurtosis. Now, skew is simply how asymmetrical a distribution of data is. Understanding skew and kurtosis is really important in understanding the shape of our distribution of data, and this will come into play a lot more later on as well. So for now, let's just press forward and learn by doing. Let's go ahead and close out this help section up in the top right so we can see our console a little bit better, and then go ahead and configure our script to run in a new terminal. Now we're going to go ahead and rewrite our import section so we can import our data. This time we're going to add a little bit of filtering. So starting off with an iterator and then defining an empty list which will hold our data. We're going to just do income this time. Standard with open, name of our file. New line, you can just leave that empty. It'll default to the new line character. And we'll just call this my file. Next, we'll go ahead and add in a variable called data. We'll define this as csv.reader, and we will read in everything from my file. Next, let's go ahead and filter this using a for loop. So we'll loop through every row in data, add one to our iterator, then start filtering our data using a series of if statements. It can be more efficient to nest this into one longer if statement. However, we want to keep this as simple to read as possible, as this is targeted at individuals with either no prior background with Python or very little background with Python. Now, our first if statement just filtered out the header, which was inc total. Our second if statement will filter out any income that is 1 or less. This is because an income of 1 is coded as net positive, income of 0 is coded as 0 income, and an income of -1 is net loss. The last if statement is just what we've been filtering out before, which is the 7 nines, which is coded as not applicable. If a variable passes through all these if statements, it'll be appended to our income data list. Lastly, if we get a data set of size 30,000, we'll just go ahead and break out of the loop. This is so we can just look at a smaller subset. It'll be faster for us to calculate. You don't have to do that if you don't want to. Now let's just make sure our list worked out correctly. We'll just go ahead and take a look at the first element in our list. And yep, we can see 10,000. We're going to remove the print statement, and that sets us up to get going with calculating kurtosis. So in calculating kurtosis, we have to use almost all the stuff we've already learned in our previous videos. So we'll start off by getting our sample size, and we'll just define that as the length of income data. Now, let's go and print this out so we can see the actual size of our sample data. So we know how much we ended up filtering out. We ended up with 21,000. We could put our iterator in a different place and still end up with 30,000 if we wanted to, just 30,000 that fit. I'm not going to worry about that too much here. So let's go ahead and move on to calculating our mean. So we start off with summing up all of the income data we have. Let's go ahead and make a loop to do that. We have an empty variable just starting at 0. So to calculate total sum, we'll take the individual's income and add that to our total. And then to calculate the mean, we'll divide the total sum by the sample size, and that will give us our mean income. We'll go ahead and print this out as well, just so we can see what our mean is. Print sample mean, and just put our mean variable in here, run, and 39,000. Now that we have our mean, let's go ahead and calculate our variance again. To do this, we will start by defining a couple of empty variables. We're going to be adding in a couple of extra parts into here. We'll explain this as we go, but we'll start off with our sum of squares equals 0, and do a for loop looking at our income data. So we will calculate our deviation score. Our deviation score is just the difference between a given income and the mean that we calculated already. To calculate this, we'll just take the squared value of our deviation score. We'll do this a little bit differently than previously. So deviation score squared plus the sum of squares. And once we loop through all of that, that'll give us our total sum of squares. We're going to add a couple of other variables here now. The first one we'll call S3. We'll define this as our deviation score cubed plus our previous values added to our S3 variable. And then we'll define S4, which is the same as before, except we're taking it to the 4th power rather than the 2nd or 3rd. Once we have these typed out, we can define our variance as the sum of squares divided by the size of our sample minus 1. We have an error right here. We'll convert that equal sign to a plus sign, hit save and run, and that will give us our variance. Now that we have that, we'll go ahead and give ourselves a little bit more room and then calculate our standard deviation. Again, this is just taking the square root of our variance. And we're going to do this by just taking it to the power of 0.5. That's the same as the square root. We'll go ahead and print this out and take a look. Now with our mean, variance, standard deviation, S3, S4 all in place, we can start actually looking at kurtosis. For ease of typing, we're going to just redefine our sample size to n. Now let's go ahead and define a couple of other variables. We're going to start off with S2, which is just going to be our sum of squares. And we're going to go ahead and make M2, which is our sum of squares divided by our sample size. Then M4 will just be our S4 variable also divided by the sample size. This will set us up to calculate our population kurtosis. Population is when you have access to all the data for an entire population, so like everybody in the United States, for example. And this is just simply our M4 divided by our M2 squared minus 3. The minus 3 is just in there, so a 0 kurtosis is actually a numerical value of 0. Otherwise, no kurtosis is 3. And we'll go ahead and print this out, and then hit save and run and take a look at what we get. So our population kurtosis is 28.8. So next we'll calculate our sample kurtosis, and this is going to be a mess compared to the other formulas we looked at. So this deals with our degrees of freedom. So we'll take our sample size and multiply it by n plus 1, so our sample size plus 1. And then we'll take that and divide that by n minus 1, n minus 2, and n minus 3. That entire term will then be multiplied by n minus 1 squared. The last part of this equation will just have us multiply this by S4 divided by S2 squared, and then subtract everything by 3. Lastly, let's just print this out and hit run. Note that our sample kurtosis and our population kurtosis are almost identical. That's because of our sample size. So that's something to bear in mind when you're choosing whether to calculate sample or population kurtosis. Lastly, we'll go ahead and calculate our sample skew. We do this by just taking our S3 variable and dividing that by our degrees of freedom by the cubed standard deviation. Let's go ahead and print this out and take a look. Go ahead and save and run, and we have a sample skew of 4.44. Now let's go ahead and check our work. You don't have to necessarily type this out, but I'm going to go ahead and import pandas real quick, convert our data to a data frame, and then do our test kurtosis and test skew, and we'll just see how those two compare real quick. So we're going to print out our test kurtosis, and hopefully this will be almost the exact same, if not the exact same. We'll do the same thing with skew. And yeah, we are about on the money right there. There's a few decimal places that are off, but I wouldn't consider anything significant. Pandas is a statistics and data analysis package that's really popular in Python. We're not using it mainly because I want to go over the formulas, but for those out there who are familiar with it, it's a really powerful and really good tool, and we will sometimes use it to check our work. Next time, we will go over the central limit theorem. Thank you for watching, and don't forget to like and subscribe. If you have any comments, questions, or interests you'd like to see investigated, go ahead and drop that into the comments.